Hi, I'm Claire.
I'm Rachel.
And I'm Peyton.
And we're Team 3. We're developing a Battle Frog Rube Goldberg, and we're making physics more fun in a complicated way.
So just to give you an overview of our presentation today, we'll begin by discussing the project planning phase, where we go through our brainstorming methods, including 635 method and our external research methods, and then go through our 11-week timeline using our Gantt chart. Then we will look at the customer needs we have identified for our product, followed by the product specifications, and finally an economic analysis of our product. So our product was the intention of the product is to meet the educational needs of physics classrooms under SOL standards, and these were identified through our project planning phase. So we began by brainstorming several concepts, and we used a 635 method to develop these concepts. The first of which was a lever arm that hit a ball down a ramp, and then it would bounce between two bumpers. The second had a ball roll down a ramp and hit another ball, and an Arduino was used as a sensing mechanism to determine the velocity initially. And our third concept was a lever arm, which was rotating and actuated by a servo motor, and this was programmed by the students using Arduino, and from there they would determine or calculate the angular motion. And so after our brainstorming, we went through external research where we established competitive benchmarking to compare other similar products on the market, and then we established an 11-week timeline, and this was done with our Gantt chart as seen here. And for our Gantt chart, we broke our project into 3 distinct phases. The first phase was the planning and concept development phase, and this included identifying customer needs and establishing product specifications and other details that outlined what type of specifications our product would meet. And then this was followed by a design phase where we would develop CAD models and conduct a more detailed analysis of how our product would actually work. And then this would be followed by a testing and refinement phase where we would test our product, we would create a prototype, and we would modify it as we went.
So in order to determine our customer needs, 6 interviews were conducted. These interviews were used to then figure out what the customer valued and what needed to be incorporated in their design. These customers were chosen for their experience in the classroom as well as experience with similar products. The team was then able to take these customer needs and interpret them into something that could be quantifiable later by us. And then we asked the customer to rank these interpreted needs. From this process, it was determined that the ability to demonstrate class topics in a clear and fun way was the first customer need. The second would be to perform multiple functions as well as it have multiple replaceable parts. We also decided that customers would value a product that can record information that could later be used for calculations, a product that's affordable, a product that would have interesting components, as well as a product that's compact and environmentally sustainable. From these customer needs, we were able to move forward with the process of determining what is most important through a quality function deployment, or QFD. So the team was able to create specifications that would align with the customer needs. These specifications were used to create a more quantifiable goal for the team. The specifications that we developed were able to gain a priority through the QFD through technical importance and a technical difficulty. To ensure that the team was creating marginal and ideal values that were appropriate, a competitive benchmarking process was used. The products that we compared it to were Kevia contraptions, physics workshops, and Pasco collision carts. The Kevia contraptions and the physics workshop were used to compare weight, area, and the time to set up, while the Pasco collision carts were used to determine what was currently in physics classrooms and what a teacher would be willing to pay to have a competitive product that would help improve SOL scores. So from this, the top specification is the number of sensors, and in order to be competitive in this market, we need about 1 to 2 sensors in our product. We also need a 7 to 10% SOL score improvement, and we need a 3 to 5 minute setup time for teachers. One of our important economic goals is for the product to have a cost of the market of between $100 and $200. In order to learn a little bit more about the cost breakdown, Peyton will explain the economics.
For our team's economic analysis, we started with a cost estimation for each product, part, and piece. We then used an Excel chart to calculate profit, the total revenue, total cost, after being given a total fixed cost and quantity. The total cost was dependent on a fixed cost that was given to our team of $10,000. The cost of the Arduino is also taken into account since we chose the proposal with the Arduino, and that is an extra $25. The team estimated the cost of one product to be in range of $130, as was the product range that Claire said was between $100 to $200. The parts that were also included in the price are lots of parts dealing with the 3D equipment, the ramp that we will be using, the ball, the Arduino, and packaging, since we will be shipping the product off to other schools. We added in extra money and wiggle room for the 3D equipment. That would be in room for problems with the products and making an extra plastic equipment. We had calculated that profit will be achieved after the 274th product is sold, and this amount is only 28% of our target market. Our target market was around 670, since there are 670 schools in Virginia that would use this physics product. And based off scenario 1, we had said that price is independent of demand. One of our also main economic goals was just to be affordable so that the teachers and staff would be willing to purchase it for the school. So summarizing our product and its presentation, our BRG is a hands-on educational tool that teaches physics concepts. Our target customer is an upper-level administrator that will be purchasing the teaching materials. After developing a Gantt chart and finalizing step for our product is taking about 11 weeks to finalize. The project planning stage was used to incorporate the customer needs and all the target specifications that Claire used to make the best and potential most used product. Our final product was established after a thorough analysis, and we had chosen to go with Proposal 3. Proposal 3 consists of the Arduino with a rotating lever arm, which is run by a motor. The motor will calculate and show the lever arm which way to go, which will be also moving the ball.